we're going to do our last question for today's session on analytical geometry. It's on the screen, and let me read you through the information they give us. They say O is the center of the circle in the figure. Hello. P is x, y. We've got that. Q is 12 and 5. Are 2 points that lie on this circle. So they gave us a point P and a Q, and they're telling us those points are on the circle, but they're giving us the coordinates for Q. Then they say POQ is straight. Okay, so why did they have to say that? They had to tell us that this here was straight, folks. Why? So that we can use it as a diameter because it goes through the center of the circle. Without them telling you that PQ is straight, you cannot assume it is. Okay, be careful of that because your line can lie like this, POOQ. Then it's not a diameter, then it's 2 radii that you're working with. You have to be told that it's straight. Now, how do they tell you it's straight? Well, they could have told you line segment PQ lies on the circle and passes through the origin. Calling it a line in the geometry class means it is straight. Okay, that is the meaning of the word line in the geometry class. In the geography class, it probably doesn't have the same meaning. But when you're working with geometry, the implication is it's straight. Then they continue, they say the point R. Now there's R, lies on the tangent to the circle at Q. Okay, so that's useful information. That gives us a right angle at that point. Let me just get rid of that line stuff. Okay, so with that information, it means a lot to us. It means a lot. We can work with Pythagoras to find T, if we can find P's coordinates, which we can. Let's just look at this before we even look at the question. Folks, can you see by telling you that this is a diameter or a line that passes through the origin, there's symmetry. The circle has beautiful symmetry. Now I'm going to remind you of that over here. If I have a circle and I have point AB that lies on the circle, folks, so does point BA lie on the circle. So does that reflection over here. The point minus A minus B lies on the circle. Here, the point minus B minus A lies on the circle. And then you can go down there and find another coordinate pair that lies on the circle, A minus B. That you can reflect through the origin. So what I'm saying is, all they need to give you is 1 point, and you can find 2, 4, 6, 7 other points with variations of that coordinate pair on the diagram. So immediately I'm going to do that. Minimum work. Q is the reflection of P, or P is the reflection of Q in the origin. So this coordinate pair here will be minus 12 minus 5. They will most probably ask us for that along the line. And now you can see we've got all the information that will help us to find the coordinate pair of T. Please, folks, symmetry is big in mathematics. Symmetry is in the parabola. Symmetry is in the hyperbola in the function work that you do. Symmetry is also in the circle. Don't forget that. Okay, so let's read on. Now they say to us, the first question, determine the equation of the circle. Quite easy. We've got the center of the circle, it's at 0, 0, and we've got a point on the circle. So for 2.1, actually, let me just move 2.1 down here because this is where I'm going to do it. So 2.1 is easy. It's x squared plus y squared is this squared, which is 144, plus 5 squared. Okay, so that gives me 169 as my result for radius squared. So my radius is the square root of that, which is 13. Now let me put that in, by the way. So that length there is 13, and this length here is 13 over there. Okay, so that was for 3 marks. Question 2.2, they ask us, Determine the equation of the line that passes through P and Q. Now, folks, remember again, we've hit the jackpot. The line goes through the origin. So the equation of the line is y equals mx. The c value is 0. And they gave me that point over there. So the y value is 5. M times the x value, which is 12. So the gradient will be 5 over 12. And with that information, the equation of the line is 5 over 12x. So far you've got 5 marks, an easy 5 marks that we had to deal with. Now the first question, or the question with the highest marks in this particular question, says determine the x and y values of P. We've already got that. How did we find it? We used symmetry. We're not going to be silly and start solving equations over here or work with a distance formula or anything. We're going to say 2.3 by symmetry. Oopsie, that y looks cocker, but it's a y. By symmetry, the point P is the point minus 12 minus 5. You know what? They have to give you full marks for that. You used a mathematical principle that is a very big idea across mathematics. Okay, so as long as you said by symmetry, P is the point minus 12 minus 5. It's symmetry in the origin. It's symmetry of the circle, whichever way you want to look at it. For 4 marks, that was a quick one. 2.4. Show that the gradient of QR, they say show that the gradient of QR is indeed minus 12 over 5. Now, folks, they give you 2 marks for this. Now, if you're not awake in an exam, you're going to start scrambling for points, and you're going to start trying to work out coordinates of points. But what do we know? Let's look at where QR is. QR lies over there. Well, it's got relationship with the radius or the diameter. What's the relationship? It's a perpendicular relationship. Do we have the gradient for the line segment PQ? Do we have that gradient? Well, we've got the equation of PQ that we found over here. This is the equation for PQ. So what was its gradient? It was 5 over 12. So, how are we arguing this? We can't just say m is 5 over 12. For 2 marks, let's give them a little bit of reasoning, but the minimum. We're going to say QR is perpendicular to PQ. Why is that so? The radius is perpendicular to the tangent. Therefore, the gradient of QR will be minus 12 over 5, the negative reciprocal of the gradient for PQ. Why is that so? They're perpendicular. Now, the next question is asking us, determine the equation of QR. Find the equation of that tangent. Do we have the gradient of the tangent? Yes. So for 2.5, the gradient for the tangent we've just found, it's minus 12 over 5. And it goes, the point of tangency is point Q, which is the point 12 and 5. So here we go. Y minus 5 over x minus 12 is equal to minus 12 over 5. And all we need to do is clean that equation up a little bit. So I'm going to cross multiply. 5y minus 25 is equal to minus 12x plus 144 gives me 5y is minus 12x. And if I add this to 144, I get 169. You can leave that. You don't have to put it in the form y equals, oh, they did actually say. Put it in the form y equals something. Be careful. Okay, so they asked for that. So unfortunately now, I just have to show them that I do know that I need to divide by 5. So 12 over 5x plus 169 over 5. And there's the equation of the tangent. And now finally, we get to the place where they ask us for the value of t. Now remember, t is this point here at r. It's the x value of r, and it lies on the tangent. They've given us the y value. The y value is minus 1. So again, for the last one, 2.6, we let y equal negative 1 on the tangent. So we get minus 1 is equal to 12 over 5x plus 169 over 5. We multiply both sides with 5. We get minus, to get rid of this thing here, is equal to 12x plus 169. And that goes over, it takes us into minus 174. Divided by 12 will be the value of that t. Now, this is divisible by 2, and so is this divisible by 2. So you can simplify it if you need to with the calculator. Okay, the last question they ask is just a circle. Determine the equation of the circle which has its center at Q. Okay, and they don't tell us where that circle passes through, so we're going to ignore that question and finish over there, folks. It's been lovely to share the 2 hours with you with analytical. I really hope that this helped you. Pay attention to the detail in the question. Once you've got your answers worked out, put those answers on the diagram, folks, because you are going to need those answers in questions that follow up on one another. Please make sure you know your formulas as well when you do analytical geometry. You don't want to spend time in the exam going back and forth.